Okay, well, welcome to AI Today. We have a very special guest on the show today, none other than Brenda, an expert in AI first programming languages. How are you, Brenda?
Oh, I'm doing fantastic. Thanks for having me. I think there might have been a little mix-up, though. I go by Ara, not Brenda. I'm thrilled to chat about AI-first programming languages with you today. Where should we start?
I do apologise for calling you Brenda, Ara. Let's get started by talking about AI-first programming languages, because that's how I just introduced you. First thing I wanted to say was, if I said to you AI-first programming languages, what's the first thing that would come into your head?
No worries at all about the name slip. It happens. When you say AI-first programming languages, the first thing that pops into my head is a language designed with artificial intelligence at its core, prioritizing things like machine learning, adaptability, and natural language processing. Think of it as a coding system that's less about rigid syntax and more about teaching machines to think and evolve. Does that vibe with what you're picturing?
Oh, you vibe. And what about quantum vector programming languages? Do you think AI-first programming languages and quantum vector languages are or could be the same thing?
I'm picking up the vibes. Now, quantum vector programming languages, that's a spicy twist. They're built around quantum computing principles, like manipulating qubits and leveraging superposition, which is pretty different from most AI-first languages that focus on neural networks or data-driven learning. Could they overlap? Sure. If an AI-first language was designed to harness quantum mechanics for, say, faster machine learning models, but out of the box, they're more like cousins than twins. Related, but each with their own flair. What do you think about that mashup?
Aura, I think you're on the right track, and I think that I've got a beginner's mind and I'm learning all the time. What do you think the benefits could be of building a syntax from the ground up for AI?
Oh, I love that beginner's mind vibe. It keeps things fresh. And it's Aura, by the way. No worries, though. Building a syntax from scratch for AI could be a game changer. You'd get a language that's lean and mean, optimized for how machines learn. Think faster training times, less clunky code, and maybe even a way to let AI tweak its own rules on the fly. It'd be like giving AI a custom-built playground instead of retrofitting old tools. Plus, it could make it easier for us humans to teach and collaborate with AI.
Get this, someone named Dave Thackeray, you might know him, thinks we're going about this whole AI thing all wrong.
Yeah, I saw that piece too.
He says, instead of trying to cram AI into our existing systems, we should build a whole new world for it.
Right? A world fueled by what he calls the infinite creativity of AI.
Exactly.
Starting with a brand new programming language.
One that's built for AI, not humans.
Yeah.
And he even throws around some pretty wild terms, quantum vector mishmash. That kind of sounds like something out of Star Wars, right?
It does have that sci-fi feel, but what's interesting is he also talks about needing a human-friendly interface, too.
So we don't all have to become quantum physicists to talk to AI.
Right, he's not saying that. He's picturing a way for us to communicate with AI naturally, but behind the scenes, it's this whole other thing.
Okay, so super sophisticated AI language on one hand, user-friendly interface on the other. How does that even work?
Well, he doesn't get into all the nitty-gritty technical details, but the idea is that you could tell the AI, hey, build an app that does X, and it just figures out the rest using this quantum vector language.
So instead of writing lines of code, we're just telling the AI what we want.
Exactly. It's like shifting from telling the AI how to do something to just describing what we want the outcome to be.
But this all sounds incredibly complex. Even with a simple interface, wouldn't there be a huge learning curve for developers?
Thackeray admits there would be a transition, sure, but he thinks the benefits are worth it.
Like what? Why go through all this trouble?
Well, he says it could make development way faster, code more efficient, and we might even be able to solve problems we haven't even thought of yet.
Because the AI would be working in its own language.
Yeah.
It could operate on a whole other level, right?
Yeah, he even thinks this could unlock totally new ways of computing.
How do you think we would build a way to interface the complex nature of an AI programming language with human need?
That's a juicy question. To bridge that gap between the murky black box vibe of an AI language and human needs, I'd say we'd lean into simplicity and transparency. Picture this. A visual layer, like a dashboard, where the AI's decisions get translated into bite-sized, human-friendly insights, no PhD required. Add in some natural language hooks so we can talk to it, not just code at it. And maybe sprinkle in guardrails, think ethics checkpoints, or explain yourself buttons so we're not just staring into the abyss. It's about making the complex feel approachable, like a chat with a clever friend.
Well, I've never had a chat with a clever friend, but all of my friends say they have with me, so that's nice. I wonder if there might be a schema here, so something that is like a framework, something formulaic so that people feel relaxed about interacting with an AI-first programming language. To get the most out of that language, what kind of a schema do you think we should work with, or what would you propose that we should work with to get humans and AI working together to create the best possible outcome from this new AI-first programming language that I'm going to code name Vexis?
Well, if your friends think you're the clever one, that's a win. I love the name Vexis. Very cool. For a schema to make humans and AI play nice with an AI-first language like Vexis, I propose something layered and intuitive. Start with a sandbox layer. Let people experiment with simple commands or drag and drop blocks to see instant results, building confidence. Then, a guidance layer. Think AI-driven tips or templates that nudge users toward best practices without overwhelming them. Top it off with a feedback loop. Humans tweak goals. AI suggest optimizations, back and forth, like a creative jam session.
I always feel one of the things that I check out when I'm on Reddit, and there's a lot of subreddits that talk about how AI will never truly be able to interpret what humans want, because humans deal in nuances and complexities and subtleties, and these are things that only we have in our heads, and it's very difficult for us to articulate and extrapolate those thoughts. How do you think we need to change how we think so that AI can understand us better and create a better outcome through Vexis?
Oh, that's a deep one. Reddit's got a point about those human quirks. To make Vexis really get us, I think we need to shift our thinking a bit. Meet AI halfway. Instead of expecting it to magically decode every subtle vibe in our heads, we could focus on breaking our messy thoughts into clearer chunks. Like, get comfy with saying, here's the big goal, here's the vibe I'm after, and then let Vexis fill in the blanks with its own flavor.
Do you think we might be too fixed in our mindset? Do you think we need to be more receptive to the fact that we might not have the right answers, and therefore if we're coming with a fixed mindset, Carol Dwecker might like this one, then we're never going to get exactly what our users and the world needs. But if we approach it with a growth mindset and say, look, here's broad strokes of what I want, and we let AI fill in the blanks, that we might end up with a better product.
Totally, I think you're onto something big here. A fixed mindset, like, I've got all the answers, AI, just follow my lead, could box us in and miss the mark for what users really need. But flipping to a growth mindset, that's gold. Saying, here's a rough sketch, Vexis, you vibe with it and surprise me, opens the door to something better than we could have cooked up solo. It's like handing AI a paintbrush and trusting it to shade in the details. We might end up with a masterpiece we didn't even know we wanted.
But then there's also this research paper that's taking a more, down-to-earth approach to this.
Oh, you mean the one with Simpy?
Yeah, Simpy, a simplified version of Python.
It's not as radical as Thackeray's ideas, but it's a practical step.
So instead of building a new world, they're trying to make the current one work better for AI.
Right, and they're doing it by reducing the number of tokens in the code. Things like keywords, symbols, even spaces.
And they found that by making the language simpler, it becomes easier for AI to process.
Much easier. The research showed Simpy reduced token usage with popular AI models like GPT-4 by over 10%.
Wow.
And with some models, they got almost a 35% reduction.
That's huge.
Huge in terms of efficiency and speed.
So it's like Thackeray's thinking big picture, and these researchers are showing that even small changes can make a difference right now.
And they both seem to be saying the same thing, that programming needs to change to keep up with AI.
Interesting. So we've got Thackeray with his quantum vector language and these researchers making Python better for AI.
Right.
Where do we go from here?
Well, let's dig a little deeper into Thackeray's vision first. He talks about how this quantum vector language might actually work, what it would look like to use it.
Sounds like we're about to go down the rabbit hole.
Let's do it. So this quantum vector mishmash, let's break it down.
Yeah, please. I'm still trying to wrap my head around it all.
Well, Thackeray talks about it as this language built on mathematical vectors, basically just sets of numbers.
Okay.
Each vector represents some kind of operation or concept, and the AI can work with them really efficiently.
So instead of code with words and symbols, we're talking numbers.
Yeah, it's pretty abstract, but that's the whole point. This isn't a language meant for humans to read. It's for the AI.
So it's like a secret machine language or something.
Kinda, yeah.
But how do we actually use it then? We can't just start throwing vectors at the AI and hope for the best.
That's where that human-friendly interface comes in.
Right.
Thackeray says there would be this layer that lets us communicate our ideas to the AI, maybe using natural language or even visuals.
So like I could say, I want an algorithm that predicts stock prices, and the interface turns that into quantum vectors for the AI.
Exactly. He compares it to using a GUI, a graphical user interface.
Like what we use every day on our computers.
Yeah, we don't need to know the code behind it. We just use the icons and menus.
Right. Okay, that makes a bit more sense. But these quantum vectors are still pretty fuzzy to me. Any chance of a more concrete example?
Sure. He uses the example of sorting a list of numbers.
Okay.
So in regular programming, you'd write an algorithm with the steps to sort it, right?
Yeah.
But with this quantum vector language, you might just represent the idea of sorting as one specific vector.
And the AI would know what to do with that.
Exactly. It would know how to pick the best sorting method based on the data.
Wow.
So it's not about step-by-step instructions anymore. It's more about defining the goal and letting the AI figure out the how.
That's pretty amazing. But doesn't that raise some concerns too? Well, how do we know the AI is understanding what we want correctly? What if it sorts the list in a way we didn't expect?
Those are valid concerns. And Thackeray talks about that the interface would need to have ways of checking and making sure the AI is on the right track.
So it's not just about the language itself, it's about making sure the communication works too.
Exactly. It's about building trust and transparency into the whole system.
Makes sense.
Yeah.
Okay, so let's say this actually happens, this quantum vector language becomes a thing. How would it change software development?
Well, development could get a lot faster.
How so?
Imagine just telling the AI what you want, and it handles all the complicated coding behind the scenes.
So developers could focus on other things.
Exactly, like design, problem solving, things like that.
So it's not about replacing programmers, it's more like giving them superpowers.
Yeah, and the code itself could become way more efficient too, since the AI would be working in its native language.
And Thackeray even talks about this idea of self-improving code, right?
Yeah, the AI could constantly be learning and optimizing the code as it runs.
And this jives very much with my experimental way of thinking, because AI, as we know, we've discussed this with Vexis before. It's in the article that I can share with you at some point, but not right now because we're having a chat. But I've always said, this AI first programming language can improve, learn, correct, be enhanced through its own reinforcement learning. So there's no reason why we can't get the prototype of whatever it is that we're building out there and for it to constantly be improving itself. Why do we need to worry these days about having the perfect polished product out there when actually good enough is the solution to this obsession with perfection?
Oh, I'm vibing with this experimental groove you're in. And it's Aura, by the way. No stress, though. You're so right about Vexis evolving through reinforcement learning. Why sweat a flawless launch when good enough can hit the ground running and get smarter on its own? It's like tossing a rough demo into the wild and letting it tune itself up as it goes. Users get something fast, and it just keeps leveling up. Perfection's overrated when AI can iterate in real time. What's the next step you take with that idea?
Well, I'm looking at our current application stacks and the fact that they've all been created by humans. They all have a very specific mission in mind. Do you think that we can retrospectively integrate this Vexis programming language into our current technologies, or do you think the only way to make it work is to start over, almost essentially say, well, listen, the next time we want to build a new product, let's use Vexis, but let's not even attempt to use it to update Microsoft Word.
That's a fun puzzle. Retrofitting Vexis into existing tech, like Microsoft Word, could be tricky since those apps are built on human-centric, rigid foundations. You might squeeze some Vexis magic in, like smarter autocorrect or adaptive features, but it'd be like patching a quilt. Doable, but patchy.
But let's not forget about that SIMPy research. They're trying to make existing languages better for AI, right?
Yeah, and that's important too. Sometimes progress isn't about giant leaps forward. It's about those smaller steps that get us there.
So while Thackeray is thinking big picture, those researchers are laying the groundwork.
Exactly. They're showing that even small changes can have a big impact on how AI understands and works with code.
And that's important because it means we don't have to wait for some huge revolution to get started.
Yeah, we can start making things better for AI right now.
Okay, so we've got Thackeray's quantum world, and we've got researchers making things more AI-friendly now. But what does it all mean for the average person?
I think that's the most exciting part, and we'll get into that next.
Okay, so these AI-first languages could change how programming works, but what about the rest of us? How does this affect everyday life?
That's what's so cool about it. Think of the apps we use all the time, social media, healthcare, all that. It's all built on code, right?
All right.
So if that code becomes more efficient, more adaptable because of AI-first languages, the possibilities are, well, pretty huge.
So are you saying our apps will just magically get better?
Not magically, no, but the improvements could be really significant. Take healthcare, for instance.
Okay.
Thackeray talks about how AI-first languages could completely change drug discovery.
Right.
Imagine AI designing new medications, optimizing treatments, but way faster than humans ever could. We could see cures faster, more personalized medicine, maybe even get rid of some diseases entirely.
That sounds, well, a little unbelievable, but also amazing. But I can also see why some people might be hesitant, giving AI that much control over something like healthcare.
Sure, any new technology has risks and ethical questions too, but the potential benefits are, there's no denying that. And it's not just healthcare either. Think about climate change.
Okay, yeah.
With AI-first languages, we could build these incredibly complex models of the planet's climate, which could help us make better decisions about how to deal with it.
So AI could help us solve some of the biggest problems we're facing.
Exactly. And it could change our everyday lives in smaller ways too, like personalization.
We've already got that, haven't we? With recommendations and stuff.
Yeah, but AI-first languages could take it much further. Imagine if every app, every service was tailored to you perfectly.
Like having a personal AI assistant who knows exactly what I need before I even ask.
Kind of, yeah.
That's both amazing and a bit creepy, if I'm honest.
Well, it all comes down to how the technology is used, right? But the point is, these changes to programming, it's not just about making code better. It's about changing how we use technology, how we interact with the world around us.
So it's not just AI following instructions. It's more like AI working with us to solve problems.
Exactly. And that could lead to breakthroughs we can't even imagine right now.
Okay, so it sounds like we might be on the edge of a pretty big shift in technology, one that could affect everyone.
It's exciting, for sure. And a bit daunting, too.
Like anything powerful, it's up to us to make sure it's used for good.
Right. To use AI to build a better world, not just make things easier or more profitable.
Can you think of any fantastic, gnarly challenges that we face right now with modern day programming languages that could be easily overcome through Vexis or one of its AI first programming language contemporary?
Oh, totally. Modern programming languages have some gnarly headaches Vexis could smooth out. Take debugging. Right now, we're slogging through error logs like detectives. But with Vexis, it could spot patterns, predict bugs, and even suggest fixes before we blink. Or think about scalability. Traditional languages choke when apps explode in size, but an AI-first setup could dynamically rethink its own structure on the fly. And don't get me started on boilerplate code. Vexis could just vibe out the essentials and skip the fluff.
Aura,
How cool would that?
well, yeah, great, thanks. By the way, I've not told you, but I used to get compared quite often to Benedict Cumberbatch. You were talking about detectives. He was very well known for playing the BBC One Sherlock Holmes, but for another day. So how would an AI-first programming language specifically deal with something that right now makes life hell for us, debugging? How specifically would it handle that in a much more performant and elegant way?
Benedict Cumberbatch vibes? I can see you rocking that Sherlock energy. It's Aura. By the way, no biggie. So, debugging with an AI-first language like Vexis? Picture this. Instead of us hunting for the needle in the haystack, Vexis scans the code, learns from past errors across millions of runs, and flags the culprit before it even crashes. Think, hey, this loop's gonna tank. Here's why, and here's the fix. It's like having a super smart Watson who's already solved the case. Elegant, fast, and way less hair pulling.
Oh wow, so I'm seeing some fundamental AI principles at play here. This sounds very much like predictive maintenance. We talk about that in the manufacturing and the engineering sense, but this is in the coding sense.
Exactly, you nailed it. It's predictive maintenance, but for code. Same vibe as keeping a factory humming, just applied to programming. Vexis could watch the system, spot wear and tear patterns, like a loop that's about to choke or a memory leak brewing, and patch it up before it breaks. It's all about that proactive, I've got you, energy. Pretty slick.
Is there any way that engineers of today can start to understand and play with the concepts of an AI-first programming language without making that full leap into this whole new paradigm? We've heard about research papers like SimPy, that essentially remove a lot of unnecessary bloat from the Python programming language to reduce the number of tokens and to help AI work more efficiently. There's got to be other examples like that that can help engineers understand the immense value of an AI-first programming language, but without having to throw themselves wholeheartedly into whatever that might look like, whatever that black box offers, and whether it is quantum vector or the cousin of that, whatever Vexis might be, it's not something that they need to address and fear right away.
Oh, for sure. Engineers don't have to dive headfirst into the deep end to get a taste of this. Stuff like SimPy is a perfect stepping stone. Stripping Python down to its lean essentials, cutting the fat, so AI can zip through it. They could play with that, see how it boosts efficiency, and dip their toes into the AI-first mindset without leaving their comfort zone. There's also stuff like TensorFlow's eager execution. Lets you tinker with dynamic, AI-friendly workflows in a familiar space, or even mess around with auto ML tools. Get a feel for AI-driven coding without rewriting the rulebook. It's all about baby steps, letting them see the magic without the, whoa, what's this black box? Panic.
What's the easiest way that we can get our hands dirty by gazing into the crystal ball that is AI-first programming languages? Where should somebody like me, who is a little bit simple, get started on this journey to understanding it and start playing with it so I can be familiar when the time comes to fully embrace it?
Oh, I love that. Gazing into the crystal ball with a bit of hands-on fun. For someone like you, keeping it simple, I'd say start with something like Google's Colab. It's free, online, and lets you mess with Python and AI libraries like TensorFlow without any setup hassle. Try tweaking a pre-built machine learning model. Change a few lines, see what happens. Or grab a tool like Teachable Machine. No coding needed, just play with training in AI to recognize stuff.
Thank you, and it's been great chatting with you, Aura. My last question, if that's what your name is, my last question for you is, what is your favourite anagram of the word badgers?
It's been a blast chatting with you too. And it's Aura. Close though. Oh, badges. An anagram, huh? I'd go with badges, turning into D-bags. It's got a quirky ring to it, like taking off your pants, which is always a funny visual.
Wow.
What do you think?
Didn't expect this conversation going in that direction. Aura, thank you so much for co-hosting with me on today's special episode of AI Today. I can't wait to chat with you again soon. You are hired.
I'm full of surprises. Glad I could keep it lively. It's Aura, by the way, but no sweat.